Before we start talking about whether the scriptable object is a data container or something more, we need to step back and look at how Unity's memory actually works. Once we understand this, it will be much easier to explain why scriptable objects sit between the managed and the native layers and how that affects their behaviors when we clone or modify them. Let's get back to the slide. On the left side, you can see the pie chart. The red one, managed memory, which is controlled by the C# runtime. It includes all the C# objects like monobehavior, scriptable object, list string, and also value types, int, float, bool, struct, etc. And everything in this region sits on the managed heap. It is automatically controlled by the garbage collection. And for the green part, which represents the native memory and is controlled by the Unity engine's C++ side, it stores all the assets and resources, texture, mesh, animation clip, and also the subsystems like renderer, physics, audio input. The blue one means the unmanaged memory, which allows you to manually allocate the memory by using native array and native list inside the unity.collections package, but you must dispose it manually because it is outside of the garbage collection heap. Let's zoom into the scriptable object. When we create a scriptable object by using C#, Unity will automatically create a counterpart on the C++ side, and it's called native scriptable object. And both are connected by this pointer called mcached.ptr. On the left side, all the C# objects are stored on the managed heap, such as the float, int, string, and container data type. But it also contains the references to the Unity engine objects. For instance, the texture 2D and mesh, they are not pure C# objects. They are wrappers. They contain their pointers, which points to the real native resources. On the right side, in the native world, inside the native scriptable object, the texture 2D stores GPU buffer minmaps, the mesh stores vertex and index buffers, and the for native scriptable object itself carries some engine metadata such as the reference count, lifecycle information, and serialization state, which I haven't put it here. So when we say scriptable object exists in both worlds, that means the two layers are connected by the pointer. Alright, let's look at the small demo I've prepared. I have created a simple scriptable object called demo.so, and it only has two fields. One is public int count, the other one is called public texture 2D sprite. Let's look at the experiment. In script.so clone demo, on top there is an enum called clone mode. There are three options: pollution, shallow clone, deep clone. I will switch between them in the inspector to test the three cases. Sprite renderer is required because we will directly see the texture update in the game scene view. In start, depending on the mode, we either directly reference the original SO, or shallow clone, or deep clone, where both SO and its texture will be duplicated. And also we will print 4 lines information on the console, the original and the runtime SO IDs, and the original and runtime texture IDs. In update, we have two operations. Press space, it'll increase the count. Press C, it'll recolor the texture red by using getPixels32, setPixels32, and apply. Here in the Unity editor, you can see my demo scriptable object asset. The count starts at 0, and I have assigned a texture to the sprite field. Now before we can modify this texture in C#, we need to make sure that's readable. So let's click on the texture, and in the import settings, go to advanced. Make sure the read and write is enabled. This option keeps a copy of the texture on the CPU side so that our script can read and write its pixels. Otherwise, it only exists on the GPU side and will get a texture is not readable error. And one more small detail for this demo, I'm going to set the texture format to RGBA 32-bit. Since we are going to call the getPixels32 and setPixels32, we need an uncompressed format like RGBA 32-bit, so the CPU can safely read and modify pixels in memory. Now let's start with the pollution mode. Here on the script loader object, I make sure the clone mode enum is set to pollution. Click on the original field to open the ScriptableObject asset, and check the texture assigned is the one with the pollution suffix. Then press play. I press space a few times. You can see that the count value increasing directly in the inspector. Then press C and the texture turns completely red. I pause the game and open the console. We can see that both the original SOID and the runtime SOID are exactly the same. And the same goes for the texture IDs. Back in the Assets panel, the ScriptableObject itself has been permanently modified. Both the count and the sprite are changed. The texture asset is now fully red, confirming this is a completely data pollution case. Next, let's move on to the shallow clone case. First, I reset the original ScriptableObject. I set count back to 0 and assign the texture with the shallow clone suffix. Then I go back to the script load game object, switch the clone mode enum to shallow clone, and hit play. I repeat the same steps. I press space a few times. The runtime count increases. And then I press C to repaint the texture red. After pausing the game, let's check the console. The SOIDs are different, which means the ScriptableObject itself was cloned, but the texture IDs are the same, so the texture resource is still shared. Back in the inspector, the original count on the asset stays at 0, but the texture asset has been fully recolored. That confirms this is a shallow clone. The managed object is new, but it still points to the same native texture. Let's switch to the deep clone case. On the script load game object, make sure the clone mode enum is set to deep clone. Then open the original ScriptableObject and assign the texture with the deep clone suffix. Hit play. I repeat the same interaction. Press space a few times. This increases the runtime count. And press C to repaint the texture red. After pausing the game, let's check in the console. Both the SOIDs and the texture IDs are different from the originals. That means we cloned the ScriptableObject and its texture, a true deep clone. Back in the scene, the texture we see is fully recolored. But in the Assets panel, the original texture remains clean. So in the end, a ScriptableObject isn't just a data container, it's the bridge between managed C# memory and Unity's native engine memory.